the mean. Okay, in this case, you have two variables, so you calculate the S variable and also the Y variable mean. After you calculate the mean for each variable, then you can start to calculate the covariance. Okay, so it's very similar to what you did before. Okay, so for example, if you have this point, okay, what you can calculate is to calculate the diff. So because for each exponent unit, you have two variables, right? S and Y. Okay, because you have the S value, you also have a Y value. Okay, so to calculate how the value for each this exponent unit vary or deviate from the mean of S, you just take the S value minus with the S value minus with the mean. Okay, and also take the Y value because you have two set of value, right? Minus with the mean Y. Okay, S minus with mean S, Y minus with mean Y. Then you can subsolve the how vary of each of the exponent unit away from mean. Okay, same as this one. So this one you also can calculate different in S. Okay, the S value from the mean and also Y value from the mean. Okay, so this is what we call the deviation. Okay, so difference. So for example, if you calculate the S, so this is the formula, so you can do the calculation and you get one value. So in this case, it's a negative deviation. Okay, because it's on the left-hand side of the mean of the S. So if this is smaller value than mean, so if you take this value minus with the mean, you will get a negative value. Yeah. So how about this one? So you need to calculate the Y, right? So this one you already can see that if you follow this principle, so this Y value is above of the mean Y. So you expect that you get a positive deviation. Okay? So what you need to do next is to multiply them. Okay? Then you get the cross product. Okay? So if you have one negative value multiplied by one positive value, you get negative value. Okay? So this is how you can calculate the deviation. If you plot the mean S and mean Y, you can divide your plot into the 4 different quadrants. Okay, 1, 2, 3, 4. Okay. Okay. So that means that all the value in here you will have a negative value. Okay, because all the value here, all the point here is above of the Y mean, but it's smaller than S mean. Okay, so that means that this value always negative, this value will always positive. If you cross these two value, okay, you just multiply these two value, you always get a negative. So you know that all this value, if you calculate, will be negative. Okay, so now we move to this quadrant, okay, the third one, and see what happened. So for this one, you can see this value is smaller than the mean of the S value, right? Okay, and this value also smaller than the Y, the mean Y. Okay, if you do the calculation for the first one, you will get a negative deviation for the S and negative deviation for the Y. Okay, if you multiply these two value, negative value multiplied by negative value, the negative sign will cancel each other, then you get a positive value. So that means that all the point here, okay, all the point here, all the data point here, the value is smaller than mean S and mean Y. Okay, so that you always get the negative deviation for S and negative deviation for Y. If you multiply these two values, you always get the positive. So all the deviation here are positive value. Okay, the green line show the positive deviation. Okay, the red color line show the negative deviation. So that means that if you have negative positive, if you multiply them, then you get a negative. Okay, then this one you have all the negative deviation for S and Y. So negative multiplied by negative, you get a positive. This one, all the deviation is a positive value, then you will get a positive. This one is one negative, one positive. So the cross product will be negative. So all the value here will be negative. Okay, so this is how you can measure how if the two variables vary together in the same way. Okay. So this is how it look like. Okay. So in this case, you can see that they do not vary in the same way because some of them is a negative deviation, some of them are positive deviation. It's not vary in the same way. Okay. So this is why if you look at this plot, it seems that there is no relationship, okay, between S and Y variable. Okay. You have learned about covariance, okay? Before you learn how to do the calculation, right? You just look at this plot and you can explain already. There's no relationship between these two variables of this data set, okay? Because there's no variation, right? Okay, no variation. Okay? There's no clear strand that if the both variables vary together in the same way. This one, okay? One variable is vary somehow, but another variable does not vary that much and do not vary together, so you cannot observe any relationship. This one, okay, similar to the previous case, now just the opposite for Y. This one, there's no relationship, right? Because you have some value which is positive, so this one is positive. If you remove all this red point, okay, this one, okay, just keep this one, then you see there's a positive relationship, correct? So then you have the set of the data in a negative deviation, okay? So if you remove all this green point, then you might be also some negative relationship, okay? So now you have a positive and negative and together in the same plot. So this one is different. So this one you know that there's a positive relationship, correct? And very strong. Why? Because all the point is in the positive deviation quadrant, correct? Okay. And there's nothing in the negative. Okay. Even though if you have something in the negative, just say just 2, 3 points, you still observe some positive relationship, right? Because there are most of the point is co-vary in the same way, most of the point. Okay. So this one, all the data point is in the negative quadrant. So you have a negative relationship. Similarly, if you have few points here in the positive, it still will not change the result too much. Okay, because most of the point in the negative quadrant. Okay. After you calculate each of the point, the deviation. So this is how you calculate, right? So for each of the point, then you have to summarize it. So the easy way to summarize the calculation in steady state is to sum them up. Okay. So this is what you call the square cross product. So this is square cross product. This one. Okay. So what you need to do, you need to sum them up. Okay. So you just calculate the each of the S, how much it deviate from the S mean. Then for the same data point, same experiment unit, you look at the Y value and how far the Y value deviate from the mean Y, and then multiply these two values. Then you get the cross product. After you have done for the first point, you can calculate for the second point, and so on and so forth, until you finish everything. Okay. After that, you just sum all the value. So in this case, you can see that all the value is in the negative quadrant, right? So you can expect all the value are negative. Okay, all the value with the negative sign. So if you sum them up, you will get the final result will be negative sum value, right? Okay, because you have a negative first value, second value, just add them up. Okay. Then for second one is the opposite. So for this one, you have all the deviation, all the calculation for the square cross product are positive. So if you sum all the positive value at the end of the day, all the positive value, you get some positive value. Okay. And for this one, because some of them are negative, some of them are positive, if you sum them up, the value might cancel out each other. Okay. So you get either negative or positive value, but the value will be smaller, much smaller, because it's not cumulative. Okay. Because it's a plus and minus sign here. So you can use the covariance or sum or square of cross product to give you some idea what type of the relationship, positive, or negative, okay, positive or negative, first thing, and also the strength of the relationship, the value here. What is the value? Okay, because all this value is negative, so they will add up, so the value will be larger than this one because they cancel out each other. For this positive one, all the value, if you add out, it will be very large, much larger than this one. So they give you the strength of the relationship and also the type of the relationship, positive or negative. Okay, so this is how you can calculate. Of course, if you have more data point in your graph, in your data set, the value will become larger, right? So you need to standardize it, okay, with the number of the data point. So just like how you calculate the variance, same thing. So you have to take this value that you calculate just now, the sum of square of cross product, divide by the degree of freedom. So the degree of freedom is just n minus 1. Okay, so this is how you calculate the covariance. Okay, before you divide by the n, it's not called covariance yet. It's a sum of square of cross product. Okay. So this one we'll discuss in a separate tutorial. Now you know that if you use covariance, you can know the type of the relationship, positive or negative, and also the strength. So the strength is a value. However, if you remember the second concept you have to remember, this value is strongly influenced by the magnitude of the variable unit. Okay, so for example, in these two dataset A and B, okay, so they measure different things. They ask the same question: is there any relationship between the right foot and left foot size? Okay, but one for dataset A, the question is on the human. For dataset B, the question is for the elephant. Okay. So if you just calculate, if you summarize your data, this is how the graph look like. So just for the graph, even though the unit is different, the relationship show the same trend, right? It seems like the strength is the same, and also the type. So it's a positive relationship. So that means that both of them are positive, and their strength is the same. So that means that the value should be more or less the same. Okay. So far what you have learned is just to calculate the covariance. So this is how you calculate the covariance. You can do it in Excel. So you just calculate the mean for S, mean for the Y variable. After that, you calculate the deviation for each of the mean and Y for each variable. Then calculate the square of cross product. After that, you sum them up. Okay. After you sum them up, then you divide by the degree of freedom. Okay. Then you get this value. So you just do this for A and B. You will notice that the value is different. Okay, this cannot be correct. Okay, because they show the same strength of the relationship. Okay, so that means that we need to standardize it. Okay, the difference is caused by the unit of measurement. So both of them are cm, but this one is much larger. Okay, in this kind of the population. So we need to standardize it. So one way to standardize the measurement of relationship is to divide by the standard deviation. Okay, so you can calculate the standard deviation for S, standard deviation for Y, and then you just divide your covariance. So this is your covariance. Okay, divide by standard deviation for S, then multiply by standard deviation of Y. Okay. After you have calculated this, okay, you can simplify the formula. Okay. Then after you calculate this, then this is what we call the R value, correlation coefficient. So now it's the same data set. So I'm going to want to show you after standardize. So after that you calculate the sum of square for S, sum of square for Y, for you to calculate the standard deviation. After that, you get this value, then you calculate the standard deviation S and Y. Okay. What you can do is just take this value, 1190.75, divide by this 2 standard deviation. Okay. Then you get the R value is equal to 1. Okay. So if you do the same thing for the dataset B, you just calculate the standard deviation. Okay, then just calculate the R. You will get the R also equal to 1. Of course, they will not put the positive signs. If there's no sign, that means this value is positive. So now you can see that after you standardize it, then both data sets show the same kind of relationship, positive, and same strength. Okay. So this is how you can calculate the R. But the next thing you have to do, because this is just a value, right, that you calculate, you have to test whether this R value is significant or not significant. Okay. So before you can test it, then you need to calculate the standard error for R. Okay. So this is a formula, you just memorize. Okay. So it's 1 minus R squared, take this value, divide by n minus 2, and then square root. Okay. After that, once you have the R, you have the standard error for the R, then you can calculate the T value. Okay. So the T value is R divided by standard error of R. Okay. So actually this is same as a t-test. Okay. Very similar to the t-test. Okay. Then after that, so this is a formula. So as usual, you have to define your statistical hypothesis. You don't have to write this out, but you just have to know this. Okay, you have to know two hypotheses. One is a null hypothesis, another one is the alternative. So this is a R, right? R equal to 0, R not equal to 0. Of course, the R that you calculate cannot be 0. There must be some value because it's a sampling, right? We remember. Okay, but we want to test it. So you just plug in the value. Okay, and then check the degree of freedom. So this one just refer to the T table. So you have to define your alpha. So for this kind of test, always two-tailed test for correlation, and then your V. So your V in this case is n minus 2. It's not n minus 1 because you have two variables. Okay, so it's n minus 2. You use this, okay, to refer to the T table and get the critical T value. And then you also have the T value that you calculated. So you just compare your calculated T value with the critical T value. If your calculated T value is larger than critical T value, then you will reject the null hypothesis. Okay, then you will find the R is not equal to 0. That means that the R that you calculate is significant. Okay, so when you report the value, you always report the R, N or degree of freedom, and also the P value. Okay, so the R is the one that you calculate. N is a number of the data sample size. N is a sample size or number of your data, or you can report degree of freedom, okay, and also P value. If you want, you can report the T value as well, your calculated T. Before you select the correlation for your analysis, for the analysis, you have to make sure there are a few assumptions you have to follow. First is that, so the correlation is assume the linearity. So they assume that from the calculation you can see already, only when your data is linear, then the relationship will be significant. If there is a relationship, but the relationship is not linear, then you should not use the correlation. But you never know before you collect the data, right? So that's the reason why you have to do some background research, to read some paper. Okay, maybe some paper already done some research before, then always say that for variable S, the relationship between variable S and Y is not linear. Okay, in this case, you have to use the other relationship test rather than a correlation. Similarly, you also need to make sure your data is normally distributed for both variables because you're using the parametric test.